This is my final video on creating a Kubernetes cluster with DevOps and with Jenkins. So my objective here was to, in my final video, was to build a Spring-based, Tomcat-based Java application and deploy it into a Kubernetes cluster. So I was able to finally build a kube cluster. I've been using this little app here as a demo app, and I'll refresh it a few times. This thing is running now on a Kubernetes cluster. I have 3 nodes in this cluster, and let me show you those nodes here. So here's my 3 cluster nodes, and these are basically VMs, Ubuntu 20.04 VMs that are running. So this took some time. I probably have 4 complete days into making this work, and some of that was because I was using bare metal and not a cloud provider. But anyway, this thing's finally going, and let's show you around how it works. So quite happy with it. So I first started off with my first demo with this little Tomcat demo, which would not run in a container. I'm not sure why, but then I started over and I got this pet clinic code. And so what I'm going to do now is I have the application running, and it's showing this dog and this cat, which are very cute, but I'm going to change them to something different. So I'm going to alter the source code and do the whole build from start to finish. So let me find the window that has the code in it. Here it is. This is our application here. And if you take a look in here, I'm way down in the application now, and I know for a fact that, whoops. I know for a fact these PNG files are the picture here, and those are compiled into the source. So I'm just going to change one of these like in the last video. So I'm going to do a copy, and I'm going to find this file here with different pets, and we will then overwrite this one called pets.png. And that's that. So now if I commit this code up to GitHub, this will start to build. So let me show you around GitHub here. So basically, these repositories here, I'm using 2 of them. I have the source code here in this Pet Clinic Java Spring app. So this is source code that I pulled from a different repo that some kind person made, and it's great for demos. So, and I think it's to show off how Spring works. So anyway, I'm going to build from this code, and when it's built, just to make it look more real, like it's at a real company, I basically push the artifacts up that are built up into here. So these files here, ingress, YAML, pet clinic service, these are all used to deploy with the containers with micro K8s. So I need those, and those are taking some time to figure out. And the target here is the jar that we need to run this thing. So, and these files are interesting. First, you want to get the pet clinic working. So Kubernetes has about 3 steps to it. You want to get the pods running, which this file does. You want to get a service running that talks to the pods basically, and then you need some type of load balancer or ingress. So ingress was the easiest one to do, so I used that. So if you want to get the pods running, here's how to do it. And here, this matters to this app version. It's really critical that you get that right. And you call a deployment, and I'm calling this thing the pet clinic deployment, and other stages down the road will refer to this label. And I'm running 3 replicas on each of my nodes to give it full fault tolerance, and that's about it. Now the part that was really difficult was this. So I read in the literature from many blogs that I didn't want to use Docker. I don't know why. I just didn't want to use Docker. I didn't want to use Docker IO. So I wanted to use a local repository. And there's something called Container D that is hosted in micro K8s that is its own repository. So I had to name this image this exact name so it would work. And what happens is when this is loaded into the container D in micro K8s, this becomes a part of the cache. So it's not like a latest or a new, it's just local and it becomes part of the cache. So it's simply there. And if it's asked for, it comes in without a pull. So we don't have any pull from Docker or pull from anywhere. It's not a pull because it's in the cache already. This was really, really, really hard to understand, really hard. And so the Java application runs on port 8080, and then we're going to run this thing on the container. We'll also be listening on 8080. So that's how that works. The next thing we do is we do a service, and that's like an interface between the ingress and the app. And this is pretty simple. You name it something. Well, that's wrong. That's something I'm not using anymore. What am I saying? This one, the word service. Okay, like I said, very simple. And you want to call it a service. You need to get the app version right. And this pet clinic service here refers to the former file. It will bind that label on the deployment. And pet clinic app. And again, we're going to go with 8080 and 8080. Real simple. So this thing will grab on to 8080 on the pods, and it will talk 8080 out to ingress. So that took a while to figure out. Let's go back to the last ingress here. And this again is very simple. And this again took a long time to figure out. Getting this label right is critical. If this isn't right, this is not going to work. And you'll get warnings saying that it's wrong. So I was getting warnings about that I had to use this label and that wouldn't work. So I'm still in beta version here, but hey, it's working. Anyway, this is called an ingress and you name it something. You get the path right, and of course you want to get the service label here of the former file we viewed. And you want to talk to that on 8080. And I thought you had to explicitly tell it you want to talk out on port 80 on the internet, but nope, it just defers to 80 on its own. So that was interesting. Okay, so that's the guts of getting Kubernetes working. And I know it's not enough right now, but let's go into the steps of how this works. So here now we have Jenkins, and how this goes is we first do the build of the source. We do that. And then let me make sure I get this right. We push it to the repo. So I pushed up to this repo here. And it goes into the repos here. So that'll go into this stage pet clinic. And then I pull that back down. So I'm simulating Artifact or something with this. I'm simulating, a local repo at some company. So then we'll containerize that. I'll do a get clone, bring it back down, containerize it. And once we're containerized with a Docker container, I'll save it out of Docker. And then I'll deploy that to, nope, I don't do that. I deploy that right here to the K8 cluster. It's been a long week, I apologize. So let's see if this thing's building or not. Okay, so I haven't built in a while, and while I'm going through this, I'm going to set a build in motion. So we really want to change, well, I'll do that later. I'll describe how this works. So the first thing we do is this build pet clinic, and let's go through the code. So that on Jenkins here is basically, I use scripts for the whole thing here. So in Jenkins, using get, and I'm pulling off of this repository on GitHub. Main branch. And here's a hook that comes in. So GitHub is going to call this hook and start this build if I do a check-in or a push to the GitHub repository. I don't care about the workspace, so I delete it before it starts, and then we just basically run some code here to build. Actually, this thing's very simple. Boy, it's been a while. This thing just runs POM. That's all it does, and it builds. So that's a very, very simple thing. And then we push the guts of it up. So it's really simple. And I think with this one, I use a shared workspace. Let's see if I do here. Advanced and advanced. Okay, here we go, advanced. So there's one part here where I do use a shared workspace, and I'm trying to find that. No, don't see it. Anyway, the workspace is shared, and the next thing I do is I'll just push this thing up to the Git repo. I'm trying to find this shared thing here. Here it is. Geez. So yeah, I'm using a shared workspace in both of these jobs. So let's go back to the second job. I just got this working, so I'm sort of shell-shocked. So let's go back here to the dashboard, and the next thing we're going to do after the build is we're going to push this thing up to the repo. So that one is here. And again, we're using a shared workspace. I'm just pulling the bits out of that first workspace into this one. So if you do an advanced here, you'll see we're using the same workspace. And so I'm just pulling stuff out of that. And got some credentials in here to talk to my GitHub. And so first I basically pull out anything that makes this look like a repository. And I'll init it again. And I'll take out the git ignore. And I'll start just adding files here because really I'm just using GitHub to store files like an artifact or something. So I'm just trying to store artifacts. So anything here that I want to make this thing run down the line, I'm throwing it up into GitHub. And that's the jar we built in the first build. These files here are used for making the Kubernetes go down the line. So those were critical too. And it's very simple. Once those are all added, then I simply will push this thing up to the GitHub. And that will land right here in this repository here. So everything that I've added here, these files here, you see them all here. And of course, there's the target too. So we toss the whole target in here, and the target only has one file. That's all we need. And sure enough, there it is. Okay, so that's the caching it to a repo part. Okay, let's go back up to the dashboard here, and it gets a little more interesting. So we do a push. Now, once it's pushed up there, I can pull it back and start working on it. So the next thing we do is use Docker to make a container out of it. So Docker is installed on the build server. And here we, as I recall, don't have a shared workspace. We start over because I'm pooling, so I don't need a workspace that's shared. And sure enough, you'll see here that we're going to do a git clone. So this guy here is pulled down, the whole thing's cloned. And so here I found it, I don't know, easier, I guess, to make a Docker file in place. So I just basically touch a file and I make the Docker file right here to do the container build. I keep it here in Jenkins. So anyway, I should probably check that in, but that's what we do. And to make your Docker file, I'm using a Ubuntu build. I'm updating it, installing app-utils. I put the JDK in for the running of the Spring app. Put my email in. And here I'm adding the jar file, which is critical to make this thing go. And then we'll execute it. So this starts the app up, and we expose port 8080. which the pods need to run, and that's about it. So the most important confusing command, it took me a long time, was this one here, this docker build command. So I want to get rid of this Docker image later, so I put a label in it called my pet clinic, and down here I will prune it and get rid of it because I don't want it just laying around and causing me storage headaches in the future with these things adding up. And then I'll save it. So we're in Docker now, and I've built this container image in Docker. To extract it out of Docker, I will do a save, and this is the tag that we gave the image right there. So there's a tag that we've used in our file, in our build here. So our tag is right here, same tag right there and right there. And so now we're going to save it. And then I'm going to delete the old image. Once I save it to a tar file, I'm going to delete that. And this is saved in a shared workspace. So again, we're using a shared workspace here, as I recall. Let me take a look and show you that. Advanced. Yep. So we're using a workspace now called Pet Clinic. So now we go off to the most exciting part of the whole thing, which is the Kubernetes stuff. So go back, dashboard. So finally, we want to run this thing on our kube cluster. So we come to this section here. This runs last. It takes a while to run, as you can see. Anyway, let's take a look in here. This took a while to figure out, a long time. Okay, so again, we're doing our Jira updating here as we go. And I can show you again, this is a shared, it's a shared workspace, as I recall. And now we'll get down to how it really works. So I'm on a server right now called build. All this stuff runs, Jenkins runs this on my agent. It's on a build server. So I have one server called build.jeffreyfall.com. That's the build server. All this stuff runs on a build server as per Jenkins agent. So now I have keys between the build server and the production server. So the account called Jenkins has keys between the build server and all these productions here. So all I do is this petclinic.tar is actually an image. This is actually my container image. I should call it petclinic_container.tar, but it's basically a container with the guts in it that we built before in the last build, container build. So I'm going to copy this container to each server. And why that is that when these things fire up with replicas on each server, they want to pull from the cache on each server. So each image is cached to the container cache on each server. And then when that's fired up, it's used. So then I have to put these YAML files on production 1 or production, which are going to be used to actually start the services. And then here we actually then want to remove images that are left before. So in the last build, I would have made these images and I want to pull them out first. So because I'm replacing them, I will yank these out of the cache. And then here we'll simply put them back into the cache. So that's done on all three servers. That's done on production server, production 2, and production 3. Those are all members of the kube cluster. Okay, and then this is where we actually do some work. So we're going to use micro K8, the kube control command, and this will delete the pods. So the pods I were running get deleted, and they basically delete from the internals of these files. So they pretty much can read these files, and kube control knows that yes, it'll delete all that. So all the pods get put to sleep, deleted. I'll wait about, well, I was waiting 5 seconds. I guess I don't do that anymore. And then I'll spin the pods up. So here we're going to spin up the pods again with those files, and then we're going to spin up the service which connects the pods, delete it, stop it, and then create it. And then finally for the ingress, we'll stop and start the ingress. So now might be a good time to look at those files again and see how they look. So you can see the pet clinic uh, service here. And let's see, I want to look at the YAML file. So the first file that Pet Clinic uses is this deploy file. That's the first thing we do here. So the deploy right here, it's using this file minus F in this file path of this file here to figure out what service, what to do. So it pretty much knows, yeah, Pet Clinic deployment, let's get rid of that. So through replicas, it knows now from this file how to get rid of that. And the same thing for the other two here for the deployment. We looked at that. The service and the ingress. So the service is next, and as we said before, it's quite simple. It just keys off it's named Pet Clinic service, and it goes off the app Pet Clinic. And Pet Clinic, of course, is in this first file here. So you can see that the Pet Clinic is right here. That's it right there. So that's how that works. The third file here is the one that connects us to the outside world. So the ingress doesn't do a lot, but it does do a lot. This is sort of like a NAT where we're talking to the outside world, and it uses Nginx to do that, which I found quite interesting. So it's going to find the service, and it's going to talk through port 8080, and it opens up port 80 on the outside, so you can talk to it. So that's about that. I guess all it's left to do is run this thing. So let's run it. So again, what I've done is I have this thing running, and it's running now with this image of a dog and a cat. And I guess I could change more stuff, but changing that is good enough to show the app actually will change the source code and build. So we still got our dog and cat there. Let's go back to our source code and take a look. Oh yeah, and I wanted to say that there's some really messy stuff you got to change in micro K8s to make it work right with the internal cache. It was ugly. Anyway, let's find the source window here and start the build going. If I could find it. That's not it. The trouble is too many windows. That's not it. Okay, here it is. So yeah, so recall that I changed the images. Let's look at the PNGs again. And do it minus L. So right now, pets is queued up to be the large file. And the large file I know has different animals than the current one. So I know that'll build. So let's push this thing up. Okay, yeah, so we did modify pets PNG, which is good. Do an add. Okay, that's about it. And this push then to the GitHub will start the build running on Jenkins through that webhook. So there's our push. Let's take a look at what's going on with Jenkins. It's now building the pet clinic. So let's do a console on this thing. Whoops. There it is. Let's look at the console output if we can. Sometimes you can't see it. Sometimes, okay, there it is, console output. Okay, here's a console output of our first build pet clinic, and you'll see it'll compile all the source code here, including the new image for our pet clinic. And I can hear the fans on my server starting up with my VMware 6_7 ESXi. It's starting to work it hard. So this builds our source, and once this is built, we're going to send it up to GitHub. Okay, so that build worked. Let's go back to dashboard and see what else is going on. So now we're running this push to get repo down here. Let's take a peek at that one. And that's simply pushing up files. Very simple. So that takes a while because the jar file is huge. And what you'll see is up here on the, you look at the progress. So you'll see up here on the repo here that it'll flash that it's done eventually here. Okay, repositories. 10 seconds ago. Well, it looks like it's finished, and it is. There we go. Let's go here back to dashboard. See what's cooking now. Okay, now we're doing the containerized. So let's watch the console on this thing. So this is long. I'm not using any caching for the container build from Docker, so I'm just not caching and taking all the bits down again from the internet, which I'm probably going to have a huge bill from Comcast for over usage of my internet. Too much downloading. But anyway, it's downloading Ubuntu 2004 now. This takes a while. And this is creating the whole container. And again, our objective is to change this picture. Because right now we're still running on the cluster, on the kube cluster with the old stuff. So let's wait until it gets around to actually changing the container on the cluster, on the kube cluster. So it'll change the pods. Actually, in thinking about it, I probably only had to change the pod. I probably didn't have to restart the other services, but I did anyway. So maybe I should not have restarted the other services, but oh well, live and learn, right? I guess I was very complete. But you want to have as brief an outage as possible. And I think I get about a 5-second, 10-second outage with this thing. So there's probably a way of updating this thing without any interruption. And I would have to optimize this deployment to figure that out. I did this a very, I wouldn't say a fast and dirty way, but a way that worked for a demo. And I tried to be as real as possible. And yeah, you can see how big this thing is, like 817 megabytes. It's pretty big. Okay, that's finished. So now we're going to be building the deploying actually. So let's go back to that job. So now we're making our cluster work. So we're basically transporting the containers over to all the servers. So production as a container, production 2 as a container, 3 as a container now. We've transmitted over the kube files for the services. And we're actually, okay, now we're importing into the repositories on the actual cluster members to put this pet clinic image container into the actual caches on these servers so that when the service starts up, the pod start up, it can pull from the local cache. We should probably be pulling from a Docker somewhere, but I don't think it'd be any faster, really. Oh yeah, it would be. I wouldn't be writing to a cache. It would be a bit faster. So yeah, this is a slower way to do it. But hey, I didn't want to be pulling and pushing from Docker IO on the internet, so doing things in my own little VMware data center here. And while that's working, I'll bring up the VMware data center here, which is a tiny little computer here, actually. All right, looks like it's starting to run there. looks like we're done. So what does that mean we're done? What it means is it deployed the new container, and we should see now the different image. So here's the old container, and if I do a refresh right here, it should grab the new container. New container is running right now. Refresh it, and there it is. So this proves that our entire build has taken the new PNG and the source code and worked. So the entire app got rebuilt and redeployed. So that's that. That's how to do a app build with Jenkins, and send the bits to GitHub, bring them back down, make a Docker container, and then deploy the container with 3 replicas to Kubernetes. So let's go across the little data center here. So I'm running these 3 nodes as 3 separate Ubuntu instances here. I have Jira running, tracking progress. Jenkins is running on its own Ubuntu, and the build server, which you saw working for building. So that's how this goes. We first run Jenkins, he calls the build server, and Jira tracks it all. And these production servers are part of the kube cluster. So what about Jira? Let's see if Jira is tracking anything. I forgot about Jira, but I think it's still tracking here. Tom 2. Let's see here. Where's Tom 3? There it is. Yep. Containerize, push, build. So Jira's been tracking our every move here, as it should. All right. So let's look at the actual Kubernetes here a bit. So that's the build server. What's on the build server? This thing has Docker images. So let's take a look at these images again. This is where we did the build, the Docker image build initially. And let's see how this worked out. Yeah, so it only has 2 of them on here, which is good. And there's the size. So these got exported to tar files, and then those tar files got used on, they got put into the repositories on the container D on each node member. So let me now find a decent node member. Okay, here's the node called productions. There's 3 of these guys here, and it's still working. So let's take a look at some of the commands I've been using to run this thing, which might be faster than my memory. There we go. Yeah, so this is interesting stuff here when I was debugging here. I was running these commands. So these don't need to be root. I can run these as Jenkins because my name is Jenkins right now. Jenkins. So I'm Jenkins on this kube cluster node. And that shows we have 3 pods and all 3 are running. And then you can do fancy things with this, like you can say describe, I think. Describe is like a detailed version of what you can see on this thing. So yeah, it'll show the app name. It's pretty cool. I like this part, replica. So you can see that we have 3 of these running. It's kind of cool. Available. Okay, that's great. Scaling. So yep, and if we delete one of these nodes, it'll still run. It's sort of like storage. We have like a quorum. So let's see what else I did here. You can look at the pods here too. That's kind of fun. So this kind of gives you a history of what the pods did. It's kind of neat for debugging. You see them running 8080 here. Yeah, it's nice. It's all running. Wasn't that way a year ago, or I'm sorry, a day ago. Best effort. So kind of fun stuff. Anyway, let's cause an outage. How's that? Because Kubernetes supposedly will save us from ourselves, right? So let's look at see what else we can do on here. We saw that, we saw that, we saw that. Yeah, I did a lot of debugging on here today. And a lot of this stuff didn't matter until I figured out what worked. It takes a long time to figure out Kubernetes. There's about 10,000 parts to it, and there's many different ways of mix and matching all the M&Ms to make it work right. So I used Ingress. I could have used the Metal Load Balancer and other things, but I'm just glad it works. Okay, so let's take down server production 3. So as you recall, this thing could basically show our cluster here if I could find that command. Where is it? Oh, there it is. Okay, this one here is what I want, cluster info. So there's our cluster right there. And I don't want to dump. Yeah, okay, show nodes, get nodes. These commands make sense after a while. Okay, this is pretty cool. So this shows all of our nodes here. And I don't think I have any storage like that. No disk pressure because I have no disks. That's kind of cool. Well, anyway, let's get the nodes. All right, there we go. And now I'm going to cause an outage. So you can see here we have production 2 and 3. I'm going to take down production 3 and see how that goes. So it's running. Goodbye, production 3. It's been nice knowing you. Guest OS shut down. Goodbye. So production 3 is going down. It stopped the Snap app. And it's trying to bring down Kube gracefully. I could just turn the power off. How's that? Let's be rude to it. This is an outage, right? So let's make it an outage. Power off. And that really panicked it, didn't it? Okay, so that machine's dead. What happened to our cluster? It says there's one that's not ready. What happened to our application? Let's refresh it. Still working. What if I kill off another server? Let's kill off production 2 and see what happens. Shutting down production 2. I think when we lose production 2, it'll stop. I don't know. And again, I'm just going to halt the power here to be rude. Production 2, terminate, power off. Okay, so prod 2 is down. Let's look at our cluster now. It's struggling. So that might have been the quorum where we're in trouble. And how did our application do? It's probably down by now, right? Yep, it's hanging. So it looks to be down. sort of alive, but not really. All right, so can it recover with the power on? I'm betting it will. Production 2 power on. What do you know? No, I think the app came back on one node. It's slow. Seems like it's sort of working. Okay, let's bring up production 2. Production 2 power on. Yeah, the app is still working very slowly. Very slowly. Power on production 2. Hopefully it didn't damage anything. Here comes production 2. Looks like she's up. Let's see if Kubernetes is behaving a little better. Nope. Not yet. Oh, thinking about it. Yep, look at that. So we got two ready nodes. So Kube will work on 2 nodes. That's pretty cool. No wonder Google has good uptime. Okay, let's do a refresh. This should go fast now. It's sort of chugging along, but not real fast. Yep, there it is. Let's try it again. It's running, but very slowly. But it is running. Okay, let's bring up node 3. Bring up number 3. Production 3, power on. Power on. There's production 3 coming up. And it's up. How's our cluster doing now? Still one not ready. See if it'll reconnect. It's not going to bring it in, is it? I think it'll come in after some time. Yeah, there we go. Okay, we're back up. What about our deployments? After an outage, oh, looks to be fine. We're scaled to 3. Let's check the app again. Yep, we're back to full speed. So there you go. We never totally lost the app, it just got real slow. So that's my, I guess, intro to Kubernetes and failovers and outages and restoration. So it works pretty well. It works as described. All right, well, I hope you found this useful. Again, this was how to build Kubernetes or build a Spring application on Jenkins and deploying it to a micro KS 3-node Kubernetes cluster with ingress and no load balancer. Okay, thanks for watching. I hope you enjoyed this. Have a great day.